Hi everyone! Today our topic is very broad, and we'll cover many terms that refer to mixtures and solutions. The big difference between mixtures and solution is that in a solution, the items that are being mixed are mixed evenly. So that basically means that there's no chunks in the mixture. And when you're making a solution, you're usually pouring powder onto a liquid and mixing it. For example, if you pour lemonade mix, which is the solute, into water, which is the solvent, and if you stir it enough, it'll make the solution, which we all love and know, lemonade. On the other hand, if you shake a bottle of salad dressing, all the ingredients in the dressing don't stay mixed evenly, so it's called a mixture. So here's salad dressing, and as you can see, when I'm going to shake it really hard, and when you see it, it doesn't look like it's mixed evenly. In other words, when the dissolved particles are the solute, while the dissolving medium is the solvent, which is the liquid water. While the dissolving occurs, the solute gets more spread out evenly throughout the solvent, as shown in the image. Keep in mind that solvents and solutes can be solids, liquids, and gases. And also a fun fact is that water is called the universal solvent. A solution is a mixture that forms when one substance dissolves another. The substance that does dissolving is called a solvent, like water, because it's polar and attracts other substances. Another example of a solution is an aqueous solution. In this type of solution, the solvent is water and the solute are the sugar cubes. There are some other figures of solutions that might be cool to know. For example, a solution cannot be separated by filtering it. This is because in a solution, the small solute particles are able to pass through the filter paper, and the solvents can also pass through. As you can see in the image, the solutes they're going to remain the same basically throughout the process. So the filtering system isn't affecting anything. So now that you've learned a bit about solutions, let's jump into more specific characteristics of solutions. So one of these characteristics is a concentration of the solution. One way to think about concentration is how thick or dense a solution, how compact it is. For example, there is a concentrated dishwasher solution. So here it is, it's pretty concentrated, which means it's very thick. Or we can also think of a milkshake, which is shown right here, or a soda. So as you saw, the milkshake is clearly thicker or concentrated than the soda, which is a thinner liquid. And also another example would be chocolate syrup of a concentrated solution, because it's very thick as well. Now, with all the examples I gave about concentrations, we can now give a definition of concentration. The concentration of a solution is a measure of how much solute is dissolved in the given solvent. In a dilute solution, right here, there's only a small amount of solute dissolved in the solvent. On the other hand, in the concentration solution right here, there's a large amount of solute in the solvent. To put it another way, a dilute solution has a low concentration, while a concentrated solution has a higher concentration. For example, a dilute solution would be Vitamin water. Because whereas chocolate syrup, as we saw earlier, is highly concentrated. And I'd like to show you 1 mole of a substance. So here's the molarity of the solution. So what I just gave you was a concentration in its general terms, but we want to be more specific in chemistry. So the molarity of the solution will be written out in its full mathematical expression. So as you remember, 1 mole substance is 6.02 times 10 to the 23rd power particles of that substance. So we could find the moles of a substance by getting its mass, how much materials is in the substance, divided by molar mass, which now with this information, we can give you the definition of molarity. So here is the mathematical expression. So the molarity of a solution is a number of moles divided by the liters of solution. And now I'd like to show you an example written out in the real world. So for example, if you dissolve 5 moles of sodium chloride in 2 liters of sodium, the molarity would be equal to 5 divided by 2, which equals 2.5 molarity. Another way to say molarity is molar concentration. It's important to know that in concentration and molarity, we could bring up the subject of dilution. And now I'm going to show you a definition. Dilution is a watering down of a solution. As you can see on the far left, it's very dark color, so that shows how much concentration there is. Whereas on the far right, it's very light blue and it's not as pigmented. But also, for example, I'd like to say that salt solution, also known as salt water, can start with a molarity of 1 m or 1 mole of salt in 1 liter of a solution. But if we add another liter of salt per solution, we can dilute the solution by a factor of 2. In other words, the new concentration of the diluted salt solutions equals, and then it would be 0.5 molarity because we're dividing both of them by each other. You can say that we have decreased the concentration of the solution by a factor of 2. Lastly, we're going to wrap up this session with solubility. When a solute is said to be soluble in a solvent, we mean that the solute dissolves easily in a solvent. In the dissolving process, the small solvent particles tend to surround the small solute particles. Now at a given temperature and pressure, only a certain amount of solute can actually dissolve in a solvent. If you put too much solute in a solution, it won't dissolve, and it'll just remain separate from the solvent. When you have the maximum amount of solute that can dissolve in a solvent, we call this a saturated solution. As you can see here, a saturated solution is a solution that's saturated. So when you have the maximum amount of solute that can dissolve in a solvent, we call this a saturated solution. For example, if you have a salt solution that's saturated, but you add more salt to it, the added salt won't dissolve anymore. This is very closely related to the term saturated solution, which is the solubility of a substance or a solute. the solubility of a substance is how much of the solute will dissolve in a given amount of solvent and a specific temperature and the pressure to make a saturated solution. Now, we're going to wrap up the session with the example regarding the idea of solubility. So, I'd like to turn over and show you Kool-Aid being made. I'd like to say that the solute is a Kool-Aid powder and the water is a solvent. So the amount of Kool-Aid mix we added is the solubility of the Kool-Aid mix. Usually, we express the solubility of a substance in units of grams of solute per liter of solution, like we saw earlier in the lemonade example. Hope you enjoyed my chemistry lesson on mixtures and solution.